Hello, my name is Aidan Forsey. I graduated in the year 2021. This is my first year on the team and my first year of experience. I am in charge of aerial delivery, and during the competition, I will be a mission planner crewman.
Hi, my name is Bodie, Hoover, and I graduated in the year 2020. I've been on the team for 1 year. I got 1 year experience. I'm in the hardware department, and at the competition, I'll be the safety pilot.
Hi, my name is Alice Min, and I'll be graduating in the year 2021. I've been on the Pivot UAV team for 1 year and have 1 year of UAS experience. During the development process, I worked on the software team, and at the competition, I'll be part of the automated mission planner crew.
Hi, my name is Eric Park, and I'm graduating in the year 2020. I've been on the team for 3 years and have 3 years of experience. On the team, I'm working on the ground control station, and on the flight line, I'll be working at the mission planner crewman.
Hi, my name is Toby Park. I'm graduating in the year 2020. This is my 3rd year on the team and my 3rd year of experience. I'm the hardware captain for the team, and at competition I will be the interop manager.
Hi, I'm Wesley Park. I'll be graduating in 2019. I've had 2 years of experience in UAS, and this is my 2nd year on the Pivot UAV team. In the development team, I was the team captain, and on the flight line, I will be the safety manager.
I'm Alex Pheiffer. I graduated in the year of 2019. I have been on the Pivot UAV team for 1 year. I have 1 year of UAS experience. I was the software captain this year, and during the competition, I will be part of the automated mission planner crew.
Nikita Swatek will be graduating in the year 2021. He's been on the Pivot UAV team for 1 year and has 1 year of UAS experience. In the development team, he's worked on the transmission and receptions of the drone and the ground station. On the flight line, he will be the antenna manager.
Planned tasks. Autonomous flight will be attempted, high confidence. Waypoint capture will be attempted, high confidence. Stationary object avoidance will be attempted, high confidence. Dynamic object avoidance will be attempted, low confidence. Due to the Pivot UAV team's lack of prior software experience and knowledge of the competition, image recognition will not be attempted. Air delivery will be attempted, high confidence. Interoperability will be attempted, medium confidence. The Condor 2 utilizes a number of different onboard components. The flight controller is a PICSOC 2.1. The PICSOC is directly connected to the Raspberry Pi, which is directly connected to the Bullet M5. The Bullet M5 has a wireless connection to the ground station antenna and therefore the rest of the ground station. The PICSOC 2.1 is also connected to 2 GPSs to maximize the accuracy of the GPS. The PICSOC 2.1 also has a connection to the receiver, which is a two-way communication link with the safety pilot's RC controller. This is a layout of our ground station, including the jobs done by our flight line team. Our drone is connected to the ground station through the antenna, which is operated by the antenna manager. The antenna manager is manually orienting the antenna towards the drone. The spotter will oversee the drone and have eyes on it at all times, so he will be giving directions to the antenna manager on how best to orient the antenna. The antenna will have a link to a power source as well as to a computer monitored mission planner. Mission planner will be overseen by the 2 MP crewmen, and the data will be evaluated. The mission planner computer will have a link to the automated mission planner computer, which is run by the AMP crewmen, which there are 2 of. The safety manager will then oversee the job executions done by the flightline team. The safety manager will also make executive decisions, as the safety manager is the team captain.
Autonomous flight data. The average success rate for the autonomous flights are 69% for waypoints and 46% for landings. The total average was 71%. The tests conducted were graded on a pass or fail scale. If the copter had to go into manual mode at any point of the flight, the entire section, including the non-attempted waypoints, was counted as a failure. For example, when a battery checker went off mid-waypoint flight, the copter would manually land, and a failure for both waypoints and landings, as well as all preceding waypoints. The tests were not graded on accuracy. Please note that when the copter copter failed to take off. The flight was not counted in the log, resulting in 100%. Some common notes from the flights include GPS failure, which the solution includes adding another GPS on the copter as a failsafe. Wobbles at or between waypoints. Sudden battery fails. Solution: the minimum voltage to trigger the battery checker was raised to more quickly alert the team of any battery failure.
The waypoint capture data here shows 3 different examples using the same 3 waypoints. We show the change in distance in latitude, longitude, and altitude all in unit of feet. In the final column, we show the average change in distance, which is down here, which is about 8.1 feet. Obstacle avoidance data. The obstacle avoidance data was used with the actual copter outside, and it was done using different waypoints at each test. More tests were done using the simulated copter, though the simulated copter results were much more accurate than the actual copter results. The moving collision algorithm is still a work in progress, which is why the moving collision results aren't as great as we hoped they'd be. In this box down here, the success/total is actually an average, it's not a total like what the box says over there.
Air delivery system. Success means if the box opened or not. The average speed from the target was 7.3. The water bottle never failed to break, so we did not need a column for it on the chart.
Three full mission tests were conducted. All values on the table are given in a percentage form. The totals were added up according to the rules. Mission timelines consistently resulted in 100%, largely due to the fact that object detection was not attempted, and object detection often ends up being a large portion of the autonomous mission. The obstacle avoidance often scored low as a result of dynamic obstacles not being avoided and stationary obstacles only being partially avoided. Operational excellence scores were varying as the team is still developing experience, largely due to the fact that the team consists of mainly newly recruited members. We are taking into consideration that the airfield may consist of variables that we have not accounted for, such as varying weather as well as varying radio frequencies that may interfere. So we are expecting our scores to be slightly lower at competition.
Thank you for listening to our presentation. We are excited to see you in Maryland. We believe the team has made some major adjustments this year, and we hope to be competitive.